Alright, in this video I'm talking about logarithms, and not really the properties of logarithms, just like what they are and, how we calculate them mentally and how we calculate them using a scientific calculator. Okay? So, really, at the beginning we would say, what even is a logarithm, or why would we be interested in it? Okay, I'm assuming that you have seen this in Algebra 2, because you all have Algebra 2 credits, so you've seen the logarithms before, but oftentimes the first time around with them, they can be a little difficult. So we're going to try to make it easy this class. All right, so first we got to really motivate the use of a logarithm. Like, why would a person even need that in the first place? And, well, it's very relevant. Okay, so we know the solution to this equation, right? We know what exponent we can put on 2 to get 8. We can put the 3 exponent on 2 to get 8, right? But what about this equation? 2 to the x equals 10. Well, I know it's going to have to be bigger than 3 because 2 to the 3 gets you 8. I need more than that. And it's got to be smaller than 4 because 2 to the 4 is equal to 16. So at this point, all we can say is x is between 3 and 4, somewhere between 3 and 4. And I feel like it's probably closer to 3 than 4 because 10 is closer to 8 than 16. But other than that, we don't really have anything else to say about it. And that's why we're going to say, okay, this special exponent that we put on 2 to get 10, well, that's going to be, we'll just call it a logarithm. And that's, if you look up the etymology of the word logarithm, it has some sort of, meaning in that sense. All right, so the definition of a logarithm is, and now first I'm going to just label these parts. B is what you would call the base of the logarithm. This A is what you would call an argument. And if the log equals x, then x is the logarithm. And what I'm telling you right now, and I'll keep saying throughout this lesson and really throughout the unit, is that the log is the exponent. All right, I cannot emphasize that enough. The log is the exponent. Okay, so what you're going to hear me say a few more times, the base of the log is the same as the base of the exponential equation. So that, well, the log is the exponent. So b to the x equals a. Okay, that's the definition of a logarithm. That's not how it's written on your notes packet, though. And if you're looking at your notes packet, you've got kind of 3 at the top, and I'm going to go through all of those. And I just wanted to label all of the parts of a logarithm and tell you the most important fact from today, that the log is just a special exponent. All right, so at the top of your sheet of examples, it's got these 3 things. And this is really like, what it means to be a logarithm. Okay, so I'm going to start labeling. Okay, the base of the logarithm is the base of the exponential identity. Okay, so that means that a is going to be the base of the exponent. Okay, the log is the exponent. Okay, so a to the y equals x. Okay, basically the argument is the answer. Okay. When there's no base written, when it just says log like that in the middle, it's implied that it means base 10. Now, I really don't like this because base 10 log, I've heard they're useful in science, maybe like chemistry or something, but as far as mathematics goes, the only log that's really that useful to mathematicians is the natural log on the right. Maybe the log on the left if you needed to solve some sort of weird equation, but even still, natural log is really the only log I care about. And now I will try to make sure to indicate the base every time, but if there's no base indicated, you assume 10. And if you're going to say log, I probably actually mean natural, but maybe not in this class. So here, what this really means is log base 10 of x is equal to y. Okay? Again, the base of the log is the base of the exponential relationship. So that'll be 10. The log itself is the exponent. And the argument is the answer. So 10 to the y equals x. Over here, with natural log, ln. I would never call it ln, I would call it natural log. Or just log, because that's really the only log we really need to worry about for higher level mathematics. But, okay, this is log base e. And it's that same e number we were talking about last time. It's that number, it's a number, it's between 2 and 3. It's nothing to be scared of, right? Okay, so I can do the same thing. Base of the log is the base of the exponential relationship. The log is the exponent. And the argument's the answer. That's what we're doing today. All right, so the first type of problem they can give us is, here we've got an exponential relationship. We know about this. And we can write this as a log. So write the relationship as a log. Now remember, the base of the exponential relationship is the same as the base of the log. Okay, so I know there's going to be a log here. The base is going to be 6. The exponent is the log is the exponent. So this is going to be equal to 2. And that means I'm going to put 36 in there. Okay. Now, you may have, had an Algebra 2 course where they showed you the spiral thing. Now, I'm kind of conflicted on the spiral, honestly. I don't like it because it kind of takes away from that conceptual understanding of what is a log even doing. But I do appreciate the fact that it does cut down on a lot of errors, I guess, provided that you know how to do this. So the spiral, I guess, will help later when you go and put it back. But it would help you check 6 to the 2 equals 36. Okay, so I'll talk more about that in a little bit. Okay, 1/10 equals 10 to the negative 1. Okay, again, base of the exponential relationship is the base of the logarithm. Okay, so this is log base 10 of something equals, well, the log is the exponent, so I'm going to put down negative 1. The only thing that's left is the 1/10. So the exponent I put on 10 to get 1/10 is negative 1. That's the way that equation would read as a sentence, kind of like we did at the beginning of the year. And then a to the 3 equals 19. Okay, the base is a, so the base of the log will be a. Log of something is 9. Oh, wait, no, not 19. It's 3 because the log is the exponent. Means that log base a of 19 equals 3. The special exponent that I put on a to get 19 is 3. Okay, the next type of thing they can ask you to do is write the log as an exponential relationship. The log equation, make it an exponential relationship. So I could use a little more room on the right side, so let's skip that over a little bit. All right, and okay, starting with the base of the log is the base of the exponential relationship. Okay, base of the log, base of the exponential. So that's going to be 3. Oh, whoops. And okay, the log itself is the exponent. So that'll be 3 to the 4. And the argument is the answer. Okay, and that's true. We know that 3 to the 4 is 81. Okay, so this should be, kind of coming together a little bit. Then over here, again, base of the log is the base of the exponential relationship. So that'll be a. The log is the exponent. And so that'll be 1 over 27. And then this third one, I really like this one because it calls back to really what does it mean to be a log. Okay, so the natural log of e to the 2 equals 2. Well, we'll talk more about this when we look at the properties next time. But natural log is like log base e of e to the 2 equals 2. And, okay, the base of the exponential or the base of the log is the base of the exponential. So that's e. The log is the exponent. And that's equal to e to the 2. But of course e to the 2 is e to the 2. Or you think, what exponent do I put on e to get e to the 2? Well, I put the 2 exponent on e to get e to the 2. So that relationship should make a lot of sense. All right, next I'm going to show you how to calculate logs mentally. And these are just for the easy ones that you want to be able to do just like real quickly. Okay? Remember, the log is the exponent. So you ask yourself, you know, what special exponent do I put on 2 to get 8? Well, 2 to the what equals 8? Well, 2 to the 3 equals 8. So the log base 2 of 8, which is the special exponent I put on 2 to get 8, is 3. Okay, over here, you think to yourself, what special exponent do I put on 9 to get 3? Okay, well, 3 is the square root of 9, so you have to think back to, the last unit. What exponent is equivalent to the square root? Be the 1/2 exponent. Yeah. So 9 to the 1/2 is equal to 3, meaning that the log with base 9 and argument 3 is equal to 1/2. Over here, you say to yourself, what special exponent do I put on 4 to get 1/4? Well, you invert a number by taking it to the -1 power. So the log with base 4 and argument 1/4 is equal to -1. All right, there's a couple of special identities I want to give you just right now so you don't have to think too hard about these in the future when you come into them. Let's look at the log with base b and argument 1. Okay, so you're thinking, what, for any base b, what exponent do I put on b to get 1? Put the 0 exponent on b to get 1. So for any base b, log of 1 is 0. And then log with base c of just the same number. Okay, well, what exponent do I put on c to get c? You put the 1 exponent on it. So if you see that same thing, okay, the log with the base and argument that are the same would be 1, because take something to the 1 power, it doesn't change it. Those are just a couple of quick ones. All right, and the last thing I got for you in this video is how to calculate logs with a calculator. Okay. And what you're going to need is like this change of base formula. Now, in this course, we use a TI-30XS. We use a scientific calculator only. We do not use a graphing calculator in this college algebra at this school. If you have a TI-84, you can actually go and put in log, and you can put in your own base. But we don't have that option on scientific calculator. We're trying to do good on the CLEP test. So and the calculator you're allowed to use on the CLEP test is the TI-30XS. So if you're using a scientific calculator, this is how you're going to calculate logs on a calculator. So I guess it's the change of base formula. Okay. The log with base b and argument a is equal to the natural log of a divided by the natural log of b. Or you can use the base 10 log. This is actually an identity that's valid for any based log. And probably how you're going to remember it is that, this a is above that b there, so this a should be above that b there. And I'm going to do a couple of examples, but really this introductory lesson on logs, you just got to do the practice. So what I'm going to do is I'm just going to say, you need to do the rest of the problems on the notes packet. I might even put out a little more practice on the internet, and I might link that in the description of the video, if you feel like you need more practice and repetition with this. So let me just get you a couple of examples. All right, so The first one in red I've got is the answer to that question I proposed at the very beginning of this video. What exponent do I put on 2 to get 10? Right? Solve the equation 2 to the x equals 10. Okay, we'll do that, and we'll do that a little later. Okay, we'll write it like that. But really, we're solving this equation right now. We're figuring out what special exponent do I put on 2 to get 10. Okay, well, that's going to be, I'm going to use the change of base formula. And I'm going to say that that's the natural log of 10 divided by the natural log of 2. You can use the base 10 log if you like. It doesn't matter. Okay. There's only the base 10 log and the natural log button on the scientific calculator, though. So I'm over here. I'm just going to type in. I'm going to even use the fraction bar. And I don't have TI Smart View for the scientific calculator, so I can't show you on screen. But what I will do, actually, I'll just bring up the graphing calculator. Hold on a second. All right, there we go. So I'm just going to pretend this is the scientific calculator. And I'll just bring up the fraction bar. The fraction bar is actually much easier to pull up on the scientific calculator. But okay, I'm over here. I'm doing natural log, which looks like it's right here. Natural log of 10 divided by natural log of 2. And that's 3.321. Okay, and like I was saying at the beginning of this video, we were expecting to take 2 to a exponent a little larger than 3, smaller than 4, but probably closer to 3 than 4. And that's exactly what happened. So it's 3.322. All right. For the next one, okay, I'm just going to use that change of base formula. And I'm going to say that this is equal to the natural log of 1 divided by 243. Yeah, and the reason I did this one, it's like this one is one you could calculate by hand if you happen to know what power of 3 243 was, which most of us just don't know that off the top of our heads. So we can use the change of base formula and a scientific calculator to figure it out. And so now I'm going to just, again, bring in the fraction bar. I'm going to do natural log of 1 over 243 divided by the natural log of 3. And that's -5. Okay, so that's great. Let the calculator do the work. And then with log base 5 of 4, that's going to be natural log of 4 divided by natural log of 5. Again, we can do this with the calculator. Wait, whoops. There we go. Uh-oh. Oh, goodness, this is just not good. All right. Give me the fraction bar. See, it's just one button on the scientific calculator, much easier. Okay, so natural log of 4 divided by the natural log of 5, and that's going to be 0.861. And that's all I got for you on this video. If you're having any problems with this stuff, you really just need to do more practice problems. You need to finish the problems in the notes packet, you need to look for more log practice, and you probably need to practice with the calculator a little bit for the quiz next time.